required. So it is always less than 100%. So scope of learning is there, and no decrease in time required because is taking place, because already you have learned everything. Now, like with more and more time you spend, you come to that level where the time should decrease. Okay. So learning curve percentage must be greater than 50%. If learning curve percentage is less than 50, less than or equal to 50%, it would mean one of two possible scenario exists. So if the learning curve percentage is less than 50%, we'll see what are the scenarios. It should always be more than 50%, it seems. So if the learning curve is less than 50%, total time required to produce the additional units when production doubles, plus the time required to produce the initial units would be less than the time required for production of initial units. So what they're saying is, if the learning curve is less than 50%, the total time required to produce additional units, one extra unit, when you are doubling your production. See, I already told you, doubling of production is very important here. With doubling, what happens? You consume less time. So the total time required to produce the additional units when production doubles plus time required. So when doubling period plus time required to produce the initial units. Okay. So when you are doubling that time, whatever the time is, and the time what you are taking to make initial units will be less than the time required for production of initial units. Okay. So when you double, what happens? You take less time to make the units, correct? Now, if the learning curve is equal to 50, then it is not less than, it is equal to. Okay. So the point is very clear. When the learning curve is less than 50%, the total time you are taking to make additional units when you are doubling your production, plus the time which you took to produce initial units will be less than the time required for production of initial units. Why? Because when you enter into doubling, you definitely take less time than what you were taking when you were producing the initial units, correct? So always it is the same. Learning curve less than 50, you'll take less time. Learning curve equal to 50, you'll take what? Equal to the time required for production of initial units. Equal time, same time. Yes.
So can you please say the examples of the 2 points?
Example is coming, madam. Here the example is coming. Example is coming. Here we will see. Okay. That means if you enter into doubling period, whatever the additional units you are making, you'll take less time than what you were taking for producing initial units, correct? If the learning curve is less than 50, more than 50 means you'll take same time. That's what they're saying. Now next point. So how will you use this model? Let's go for the model now. Cumulative average time learning model. How this model works. So method, first what you have to do is calculate the estimated total time required for production. Okay. Then use the estimated total time to calculate the estimated cumulative average time per unit. Now first what we'll do is we will find out the total time, the expected time or estimated time required to produce all the units. So how will we make that? Time required for first unit into the number of doublings what you are doing, okay, into learning curve percentage will be given to you in the question. So doublings is here, sorry, this is doublings, number of doublings of units produced to date. Okay, that means you will be doubling, you will be like increasing it 2 times, you will be making it twice. So this is the formula what we used to make, what we used to find out the estimated total time required for all units produced. Once you get estimated total time required for all units produced, your next task is to find out estimated cumulative average time per unit required for all units produced. That means estimated average time you require for one unit, okay, when you are producing all the units all together. So we get all the units here, number of units, okay, the time required for producing all the units divided by total number of units produced. So what did you understand from this, madam? First, what you are doing is you are finding out the estimated total time required for all units. Divided by total units will give you average time per unit what you are taking to produce. That's it. Are you writing the formulas, madam?
Yes, sir.
Okay. If we have total time and we divide by number of units, we get per unit time, no?
Yes, sir.
Yeah.
In the first point, we can identify the total time required for all the units, and second point,
Average time.
average time for
Yes, per
1 unit.
Yeah.
In the sum, they can give the LC, sir, learning curve percentage.
Yeah, they will give all data they will give. Now we'll do a question also. Finish, madam?
Yes, sir.
Okay. Now, let's do a question. Now, a plant that manufactures cars is subject to an 80% learning curve. So, more than 50% case, correct? Now, 10 hours are required to produce the first car of a new model. So, they take 10 hours to make a car. Okay. According to cumulative average time model, the estimated total time should be given actually. That's the condition here. So estimated total time required to manufacture the first two cars will be 80% of the total time it would take. It would have taken to produce two cars if no learning had taken place. So can I say that is 2 into 20 hours, na? 20 into 80%, that is 16 hours, correct? Correct or wrong? Hello?
Sir, yes, sir. 16 hours.
Yeah, 16 hours. So it's like very simply understood, and which equates cumulative average as 8 hours. Understood fact. Like we got it here, we got it here. Divide by 2 because you are making two cars. So total estimated hours is 16 and total units are 2. So we got this. Now they are explaining this is first doubling. If you do the second doubling, that means whole square will come, correct? Number of doublings, no? Hello?
Yes, sir. It's double.
Yeah, it is doubled, yeah. So you'll get this many and divide by 4 this many. And again then third doubling, you'll be again doing cube here. So this much. Now, what you are seeing is as you are doubling, your time is reduced. Am I right?
Yes, sir.
Your average time is reduced in doubling.
Great.
So you notice that with each doubling, multiplying the previous estimated total time by 2 and then by 80% results in new estimated total time. So this this total hours required for first 4 units multiplied by 2 and then multiplied by, so what we have done is we can do that like 25.6 estimated total hours required for first 4 units. Okay, this is for first 4 units, no? Multiplied by 2 because doubling, you are doubling, na? If you multiply with 2, you will get 40.96. You are getting doubling or doubled or not?
Yes, sir. Double.
That's one. And like
Not
so
40.96, sir.
no into 80%. No, you'll get something. How much you're getting?
51 point.
That 80%, 51.2
2.
into 80%. Okay. %80 is the criteria, na, madam?
Yes, sir. Yes, sir. 40.96.
Yeah. Again,
Yeah.
yeah. Again, yes. And 32 ka 80% is how much, madam? 32 into 80%.
25.6. 25 hours.
That's it. Okay. So, madam, just go through that. Then we'll go for the next question. Once have a look at this, we'll go for the next method.
Yes, sir.
Okay. Next. Next one. This is the method 2. So calculate the estimated cumulative average time per unit for all units produced. Okay. So estimated. So previously we found out the total time. Isn't it so? This is the method number 2 actually. Now we are finding out estimated cumulative average time. So time required for first unit into learning curve, power n, that is number of doublings, will give you the estimated cumulative average time per unit, and then you have to multiply with the total number of units produced. That means when you have total, you can find out per unit, correct? Correct? That was first method.
Yes, sir.
Now second method says when you have per unit, you can multiply with total units. Correct or wrong?
Yes, sir.
So here we have per unit time. We can multiply with total number of units produced. We'll get the total time. Correct. So you can write this formulas and you can solve this. We will solve this question.
In the assembly, we will ask the cumulative time or average time, sir.
Yeah, that means that it depends upon data. If they give total, if the how they ask like total time, they ask like they give and ask us to find out per unit, or per unit we have the data and we have to find the total. It depends. At the end of the day, with doubling, what happens? Our experience increases and we consume less time. Now, so this is what like the total the following doublings refer to same plant from previous example. It manufactures cars and is subject to an 80% learning curve. The time required to produce the first car is 10 hours. So you know like 10 hours if I take for making one car, and if I make two cars, okay, so I take 20 hours, but it is like 80%, so 8 hours, correct? And if I double it, 16 hours. That means if I have cumulative average time like per unit of a car. So how did I find out that one? My formula is very simple. Time required for first unit. So time required for first unit is how much? 10 into learning curve. So what is my learning curve? Percentage 80%. Whole power 1. So I got this. I multiplied with 2. I got the total time. Same thing I can do for 2 when doublings are happening. And then I multiplied with 4 units. I get. Again for 3. I multiplied with 8 units. I get. You can do this, madam. Then we can move forward.
Yes, sir, completed, sir.
Okay.
The method 1 and method 2 same answers we can see.
No, different, madam. One in
Different,
that
sir.
you have total time. You found out per unit. Here you
Yeah.
have per unit. You found out total. That's it. That's the only difference. No? Now we are going into a different discussion. So now if they ask you the questions, so like the time required for specific block of units using cumulative average time model to find out estimated total time required to produce only 5, 6, 7, 8. Now, so the time required. So what they're asking is like time required for specific block of units using cumulative average time learning model. So now we have a separate kind of question. They are asking to find out the estimated total time required to produce only units 5, 6, 7, 8. We found out till 8 units, correct? They're only asking 5, 6, 7, 8. So what shall we do? So we have from 1 through 8. Am I right? Yes. What is 1 through 8? 40.96. Correct or wrong? Hello.
Yes, sir.
Madam, we have 1 through 4 and 1 through 8. Your 5, 6, 7, 8 lies between these two?
Yes, it lies between.
Yeah, so what we'll take is 1 through 8 minus 1 through 4. We'll get 5, 6, 7, 8. Okay. So 1 through 8 was 40.96. 1 through 4 was this. That's it.
25.6.
Yeah, 15.36 we subtract. And then if they ask only 3, 4. So it is like between like 1 through 4 I have. And then 1 through 2 I have. That is 16. So I subtract, I get 3 and 4. That's it.
Yeah.
This is done. Now we have to see this. So in the above examples, if no learning had taken place, you would have taken 20 hours. Since learning was there, we took 16 hours, correct? Hello?
Yes, sir.
Yeah, with learning what happens is we save time. So we took 8 hours for each car instead of taking 10 hours for each car. So maximum learning rate possible using cumulative average time model is some percentage greater than 50%. For example, 50.0, or if we convert into decimal this. So the maximum learning rate must be greater than 50%, because at a learning rate of exactly 50%, total time required for production of first 2 cars would exactly the same as the total time required to produce the first car. So that's what they're saying. If the greater learning rate, you'll take less time, correct? If less learning rate, then it will be a different case. So the maximum learning rate must be greater than 50%, because at exact 50%, the time required for production of first 2 cars would exactly be the same as time required to produce the first car. And that would be impossible, because like it is not, if you have learning curve, it is not possible like that. You will take less time. Understood fact?
Yes,
So
sir.
the total time required for production of first 2 cars would be exactly same as time required to produce first car. It is not possible. It is impossible. So suppose if I say 10 into 2, the learning curve percentage is 50. I take 10 hours. At a rate of 49, 9.8 hours. But it is not possible, correct? How? Less than 50%? It is impossible, correct? There cannot be like less time. Am I right? When your learning curve is less, how will you take less time? You will be taking more time. Am I right? Hello?
Yes, sir.
That's what they are saying. It is impossible. At a rate of 49%, the total time required for production of first 2 cars will be less than time required to produce the first car, which would be impossible. So even 50%, it will be just slightly more. That's it.
Just to point to.
Yeah. So therefore, when the cumulative average time model is used, average time learning model is used, learning rate will always be greater than 50 and less than 100. That's what they have proved. Now, madam, this one you have to do as homework. Yeah, I'll just, will you do that homework, madam? Next question. Hello.
We'll do.
Yeah, you can do it as homework, but I'm explaining the points here. If you're not getting, I'll explain, because this is learning model only.
Yeah, okay, sir.
No, if you're not getting, I'll explain. If you want, I'll explain right now. No worries. For me, no issues.
So I will go through, sir, and I will confirm you.
Okay. Otherwise, like if you want, I can like discuss. but like like once if you
Yes,
try better. Okay, madam.
it is learning curves only, estimated average, averages.
Okay, you will see that. No.
Yeah.
Okay. Yeah. Otherwise, I will explain tomorrow. Like immediately when you tell, I'll explain tomorrow. No problem. Now, last is benefits of using learning curve in forecasting. So, learning curve should be used in development of production and labor budgets when changes such as new products are planned. Recognizing that higher cost will occur in early phase of product life cycle allows more effective evaluation of managers, of course. So recognizing that higher cost will occur in early phase, like in of the product cycle when we start, more effective evaluation of managers. Labor cost should be adjusted regularly in recognition of fact that learning causes standard cost to decrease over time. Of course, life cycle costing in also like when you see in calculating the cost of a contract, learning curve analysis can ensure that cost estimates are accurate. First of all, they should be accurate over the life of contract, leading to better, more competitive bidding on projects. Because as the time passes, more efficiency you can expect, and you can expect a better deal in the contract. CVP analysis, as the chapter is what we are supposed to do. If learning is not considered in determining a break-even point, the result may be an overstatement of number of units required to break even. It is also used in capital budgeting process and make or buy decisions also, because what happens is like when you make or you buy, when you make, especially when you make, it all depends upon the learning curve. You also capture the learning curve effect in that. Limitation, like it is appropriate only for labor intensive operations. For machine it is not, because labor tend to learn. Learning rate is assumed to be constant. In real life, the decline in labor time might not be constant. For example, the time required might decline at the rate of 70% from first 75,000 units, followed by 80% for next 50,000 and 95 for next 25,000. They are saying that the time required might decline, but in this way, what they are saying, exactly can you expect only these scenarios? No. Maybe at 93% also the things can reduce. See, in real life, decline in labor time might not be constant. For example, time required might decline at rate of 70 for first, this many units, followed by 80 for this many and this many. So it's reducing. Reliability of learning curve calculation can be jeopardized because an observed change in productivity might actually be associated with factors other than learning. Yeah, there can be other factors also, which can reduce the time period rather than the learning curve. Product mix can be one of the examples. So, madam, this is done. Next concept is probability concept. It's a different concept. So we can take up that in next session. And then we will be entering into budget methodologies. Budget methodologies is like from here we will be preparing budgets. It's the last chapter of this book, budgeting chapter. Okay. Hello. Hello.
Oh, hello.
Yeah, we will be preparing budgets in the coming classes.
Okay, sir.
Yeah. But I don't know, madam, the recording has started at only 25 minutes recording has been done and 41 minutes I have finished taking class. I don't know what has happened. Okay. Shall we do probability concept? I'm just looking just a second. Yeah, okay then. What say, madam? Shall we do this tomorrow or today?
If you have a time, please do so today only.
Time in the sense like, okay, just a second. I had some work. Tomorrow I can sit more time, madam, if required.
Okay, sir.
I
Probability maybe, may not be
No, no, it is there. I will finish this tomorrow, probably.
Yeah, okay.
finish this and I'll enter into the budgeting also. Next chapter, next topic immediately. There, like it will take more 2 classes, madam, to finish this budgeting. Then I'll start working capital in part 2. Okay.
Okay, sir.
What I'm shocked is like I've taken 42 minutes of class and 26 minutes of recording only has been done. That is the only problem I see. Okay. Okay, madam. Then, like, what we'll do is tomorrow we'll finish probability and start budgeting. Okay. Probably tomorrow I'll try to take lengthy session. Okay.
Okay.
Okay, madam. Thank you. Thank you.